Hello, welcome to Introduction to Data Warehouse. So here the instruction information. A little bit about myself. My name is Dr. Nur Azwana Binti Ramli and I can be contacted at azwana@ump.edu.my. This is my academic background as I already explained in the previous video. There are two lesson outcomes for this course. First one is to understand data warehousing, its benefits and architecture. And second one is to understand the limitation of data warehousing. So we start with the definition of data warehouse. So what is it? A data warehouse is a historical database and should be considered as the long-term memory of an organization. To understand this term better, let us consider the database of a university management system. For the duration of study by a student at the university, his or her data will be retained in the main data store and all database operations such as insert, update, delete, and retrieve will be performed on it. This database is usually called OLTP. But once a student has left, then his or her database is usually removed from OLTP because OLTP is meant to perform day-to-day operations. However, the management may be interested in retaining the data of all students. It can be used for letter queries as well as for analysis purposes. Thus, all historical data can be vital for an organization for subsequent data analysis. All such historical records can be moved to a separate data store known as the data warehouse and may be called upon when required in the future. Data warehouses typically used for online analytical processing. In short, is OLAP to support management queries. They provide answers to common management queries like which are our lowest or highest margin customers, what is the most effective distribution channel, what product promotion have the biggest impact on revenue, which customers are most likely to go to the competition, who are my customers and what products are they buying, what impact will new products or services have on revenue and margins. For tech giant like IBM, they has devised the concept of the data warehouse. They call them as information warehouses. Since then, data warehousing systems have evolved as one of the principal technologies employed by modern enterprises for better profitability. Here is the history of developments in data warehousing. It has begun in 1960s, where batch reports were used for decision-making purpose. Analyzing and finding information using them was a serious and difficult business. On every request, they had to be reprogrammed. And then it has moved to 1970s, where terminal-based DSS and EIS tools were developed. And then it moved to 1980s, desktop data access DDA and analysis tools like query tools, spreadsheets, GUIs were developed which were easy to use but could only operational database. And until 1990s, data warehousing tools were developed during this time. They were then integrated with OLAP engine and tools. The present concept of data warehousing owes much to American computer scientist Bill Edmond, which is known as the father of data warehousing. According to Bill-Inmon, a data warehouse could be defined as a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. For subject-oriented, data warehouses are subject-oriented. They are built around the major data entity or subjects of an organization. For example, in a university, the data subject entities under study could be students, teachers, and various courses, whereas in a company, the subject might be workers, interns, services, and items. For integrated, a data warehouse integrates or combines data from multiple systems to provide a wide view of any enterprise's data. Hence, they are said to be integrated. For time variant, unlike ODS, in data warehouses, data is not always up to date as it contains historical data which is valid or accurate till some point of time or time interval. Lastly, non-volatile, which is data warehouse, is described as a long-term enterprise memory due to its non-volatile nature because the data is not updated in real time but is rather refreshed on a regular basis. Hence, the new data which is added goes in like a supplement to the database rather than a replacement. The database continually absorbs with this new data, incrementally integrating it with the previous data. So here is the data warehouse architecture. Every data warehouse has three fundamental components, which is first one, load manager, second one, warehouse manager, and third one, query manager. For the first one, load manager, it is responsible for data collection from operational systems. It also performs data conversion into some usable form to be further utilized by the user. It includes all the programs and application interfaces which are required for extracting data from the operational system, its preparation, and finally, loading of data into the data warehouse itself. It should perform these following tasks such as data identification, data validation for its accuracy, data extraction from the original source, data cleansing, data formatting, data standardization, consolidates data from multiple sources to one place, and lastly, establishment of data integrity using integrity constraints. The second one, which is the warehouse manager. It is the main part of data warehousing systems as it holds the massive amount of information from myriad sources. It organizes data in a way so it becomes easy for anyone to analyze or find the required information. It is the core of the data warehouse itself. It maintains three levels of information: detailed, lightly summarized, and highly summarized. It also maintains metadata, which is data about data. And lastly, the query manager, which is an interface that connects the end users with the information stored in data warehouse through the usage of specialized end user tools. These tools are known as data mining access tools. The market today is flooded with such tools which have common functionalities and a provision for customizing more features specific to an enterprise. These have various categories such as a query and reporting, statistic, data discovery, and others. Here are some benefits of data warehousing. Why we should use data warehousing because of these benefits. First one, unbeatable competitive advantage. By implementing data warehousing, companies can get a competitive edge over their rivals. And the second one is potential high ROI, which is stand for return on investment. Investing in data warehousing itself is a very big investment, but past reports suggest ROI growth up to 400% with data warehousing, which is making it valuable for business. Third one, cost effective. With data warehousing, it is possible to streamline the organization, thereby reducing overheads and hence reducing product costs. Fourth, high productivity in corporate decision making and business intelligence, since data warehousing combines data from multiple sources into meaningful information. And lastly, enhanced customer service. Data warehousing provides essential support when communicating with customers and so help improve customer satisfaction and retain them. Although there are some benefits of using data warehousing, there are also some limitations of data warehousing. There are 10 limitations here. First one, underestimation of resources of data loading. Then, hidden problems with source system. Third, required data not captured. Fourth, increased end user demands. 5. Data homogenization. Then high demand for resources. Data ownership, high maintenance, long duration projects, and lastly, complexity of integration. That's all for the introduction of data warehouse. For next session, I'm going to explain about the introduction to big data, and then after all the concept of big data and data warehousing, you will know how to differentiate the difference between big data and data warehouse. That's all for this video. Thank you.